This is part 1 of lesson 6.1. We're going to be doing solving quadratic equations. And so pay close attention to our learning goals. By the end of this lesson, you'll be able to solve algebraic equations graphically, also by factoring, and then understanding what it means to find zeros, roots, x-intercepts of quadratic equations, how they all relate to each other, what does that all mean? So what I need you to get again is that all quadratic expressions can be, or relations can be expressed in this form here, standard form. And there's other forms that we can use as well. So in the previous chapters we saw the standard form, which is this one over here, but we also saw that you could have a factored form, which is y is equal to, we have our a over here, and then we have our x minus s multiplied by x minus t. This is our factored form, where these are your zeros, or where your parabola hits the x-axis, so to speak. And then over here we could also have the vertex form, which allowed us to find our vertex maximum or minimum value, for example. Allowed us to see transformations to the parabola that occurred as well. So we had a times x minus h, which is the x value of the vertex squared, and then plus k, which is the y value of the vertex. So we have our standard form, we have our factored form, and we have our vertex form. For the most part, you know how to get from standard to factored, and you also know how to get from factored to standard just by expanding. And you also know how to get from vertex to the standard, and if you can get to the standard from the vertex form, then you can convert it into the factored form. There is a way to get to the vertex form from standard form. Right now you know how to get to vertex form using your factored form and the combination of your standard form, knowing points, maximum, minimum, so on and so forth, but there's another way, and we'll learn that later on. But we're going to focus on solving equations right now. So once we have our factored form, you're able to solve for a quadratic equation. And what that really means is finding the zeros. So when you solve for a quadratic equation or function, it means find the zeros. And there's other words that we use for that. So we might say find the zeros, we might say find the roots. Roots is another way to say that, so find the roots. We might say find the x-intercept, so basically where the parabola hits the x-axis. So intercepts. Not y-intercept, but x-intercepts. So for example, if I were to draw a little parabola here, these would be my zeros, or my roots, or my x-intercepts. We might also call them solutions, because we are trying to solve for the quadratic relation. So we have solutions, roots, x-intercepts. They all basically just mean zeros. Where do they hit that x-axis? So we're going to take a look at some strategies to determine the roots, or the zeros, or the x-intercepts, or the solutions of different quadratic relations. So there's a few different strategies that you can use to do that. We'll start off with example 1. Determine the roots of the following quadratic equations. And so our technique that we're going to use here is going to be just factoring. So we're going to determine the roots using the factoring technique. So here we have an a that's larger than 1, so it looks like we're going to have to use decomposition. So we're going to have to find something that when you multiply them together, they give you negative 60, because remember you do a times c over here. So negative 60, but when you add them together, you get negative 11. And so it seems like product would be negative 15 and 4, because when you add them together, negative 15 plus 4, you get negative 11. So we're going to factor this using decomposition. So we're going to have 6x squared. The negative 11 will decompose it into minus 15x plus 4x minus 10. And then we're going to group some similar terms here and then factor some components out. So we're going to get, we'll take out a 3x from this group here. So if we take out a 3x, we get 2x minus 5. And then here we'll take out a 2, so plus 2, and we get 2x minus 5. So our 2x minus 5, that's going to be our common factor there. So we're going to end up with 3x plus 2, the leftovers here and here, times 2x minus 5. Now that we have this, we can simply solve to find what the zeros are or what the x-intercepts are. So we can do, for example, set this one here to be equal to 0, so that would be our first one. So we'll have 3x plus 2. And the reason we're setting that one equal to 0 is because zeros occur when the entire equation is equal to 0. So if this equals to 0 times whatever this is, that'll give you 0 overall. 0 times a number is going to be 0. So 3x plus 2 is equal to 0. We can solve just by solving a regular equation. So we can just isolate the variable. So 3x is equal to minus 2, and you can use inverse operations, for example. And then we can divide by 3. Divide by 3. So one of our roots is x is equal to negative 2/3. So basically at negative 2/3, if you plug this value into your equation, it would equal to 0. And that would be one of your x-intercepts, or one of your solutions. And then the other solution is going to be the same idea, just using the other bracket over here. So we're going to have 2x minus 5, and we have to find when that is equal to 0. And same idea, we have 2x is equal to 5. We can divide that by 2. Divide this by 2 here. And so we get x is equal to 5 over 2. So this is another solution over here as well. So our two solutions are negative 2/3 and 5 over 2. The parabola hits at 2 points essentially. So this parabola opens from the top. I know that because my a is positive, so it looks something kind of like this over here. And this is a rough sketch. Again, I don't know my other points, but I'm just showing you that one of the zeros is on the negative side, the other 0 is on the positive grid over here. So this would be this 0 over here, negative 2/3, and this would be this 0 over here, 5 over 2, or 2.5 roughly. So now what we're going to do is we are going to do the same procedure for this one over here to solve or determine the roots. So again, we found zeros or roots, either zeros or roots. We're going to find the zeros or the roots for this. Our first step is going to be to expand and essentially simplify this whole process. So we have to expand everything and simplify. So distribute first and then simplify further if we need to. So we're going to get 4x squared plus 4x, right? 4x times 1 is 4x. Let's put that square there. Don't forget that. It's very easy to make a little mistake like that, and you have to go back and redo the whole thing. Minus 3x. The 3x is not multiplied by the 4x because it's not in brackets, which is equal to x squared plus 14. And basically, I'm going to send everything to the other side. And so just to, before I do that, I just want to highlight this here. We're making this equal to 0 when we're solving. So when we solve, we want this to be equal to 0. So just remember that as we go through this process here too. So I'm going to send all my variables, all my constants to one side. Left side or right side doesn't matter. I'll just send everything to the left side over here using inverse operations. So I'll get 4x squared minus x squared. 4x minus 3x is x, so we'll do plus x. And then 14, it's plus 14 here, so minus 14 here is equal to 0. Let's clean all this up so we get 3x squared plus x minus 14 is equal to 0. And so what we want to do is we want to factor. We're going to have to factor by decomposition again because we have our a that's larger than 1. It doesn't look like a perfect square or anything like that. So we're going to multiply that 14 by 3. And so if you do that, you get 14 times 3, which is negative 42. So we want a product that gives you negative 42. When you add it up, gives you 1. So negative 42 is our product. So we need two numbers that will do that. So 6 and 7 give you 42. We want negative 42. So it looks like we could do negative 6 and positive 7. That should work out. And now we'll proceed by decomposition. So we're going to have 3x squared minus 6x, because we're decomposing this term into the two terms we found there, plus 7x, that's still equal to x overall, minus 14 is equal to 0. And then we're going to factor out from the similar groups here to get a factored form. So we can take out a 3x from the first group over here. So 3x will result in this being x minus 2. And then we'll take out a 7 over here, so plus 7, which will result in x minus 2 over here as well, equals to 0. These are the common factors that we can take out, so we'll get end result of 3x plus 7 multiplied by x minus 2. And now we have our factored form. Now that we have our factored form, we can go and solve by making each of these equal to 0 to find when x would make them equal to 0. So we'll do this one first. So when will 3x plus 7 be equal to 0? We can isolate for the x value. So 3x is equal to negative 7. We divide by 3, divide by 3. And now we get our first solution is x is equal to negative 7 thirds, negative 7 over 3. So that means if we were to write this in coordinate form, it would basically look like this. We'd have negative 7 3 as our x value, and then 0 as our y value because we're on the x-axis at this point. And then for the other one, we have x minus 2 is equal to 0. And that one's a bit easier to solve. X is equal to 2. And so if you were to write this as a coordinate, you would get and 2, 0. These are the roots, or the zeros, for this particular relation here. Remember to simplify and solve, to simplify and group like terms first and expand to do this. If we were to write these as coordinates, again, same idea. You can pause and try it and then verify, but our first 0 was 5 over 2, and then at that point the y is, well, 0 because we're on the x-axis, exactly. And then also we had negative 2 thirds. At that point we're on the x-axis, so our y is going to be 0. So when I ask you to find zeros, solve them first by finding what the x is, and then write them as coordinates for full marks and full work as well. So that was how to find roots of quadratic relations using the factoring method. So next we're going to do a word problem. We won't have time to finish it in this video, but at least we'll have time to start it so we can see how this all applies to practical situations. So here we are. Let's do this word problem here. The user manual for Samantha's model rocket says the equation that the equation h is equal to negative 5t squared plus 40t models the approximate height in meters of the rocket after t seconds. So look at those units carefully. When will Samantha's rocket reach a height of 60 meters? So what we want you to do is we want you to find when h is equal to 60 in this case. So we're looking for setting h equal to 60. And we want to find t. So we set h equal to 60, and we want to find t at this point. So find t, or solve for t at that point, essentially. So what you're getting is your regular equation is h is equal to negative 5. Your general equation is negative 5t squared plus 40t. In this case, we want to know when the height will be 60 meters, so we're replacing that h by 60. So we're going to get 60 is equal to negative 5t squared plus 40t. And what we're going to do is we're basically going to create a quadratic relation with a c value. We're going to send this 60 to the other side and make the whole thing equal to 0, and then solve for that relation to find the t values. And we'll do that in the next video.